Yes, good afternoon to all of you. Yes, my voice is audible. Is I audible to all
Yes,
of you?
sir.
Okay,
Yes,
we
sir.
can scan the QR code for the attendance. Scan this QR code for today's attendance. So we'll wait for a minute to others to join as well. Okay, so let's start the session. So what we are discussing in the previous class, can anyone क्या डिस्कस करे थे हम लोग पिछले क्लास में तो बता सकता है? Yes.
Sir, logical address to physical address conversion.
How we are converting a logical address to physical address. Okay. So to convert a logical address to physical address in continuous memory allocation. Suppose I am considering this is my secondary memory. Okay. This is my secondary memory. And this is one main memory. Okay. Obviously, size of the main memory will be very less compared to the secondary memory. Now, what happens in case of continuous memory allocation? Now, what happens? CPU always generate. So this is my CPU. Now, this CPU will always generate what? The logical address. Now, it will generate the logical address, which will be referred to the address of secondary memory. ठीक है नहीं? CPU जो है हमेशा लॉजिकल एड्रेस जनरेट करेगा जो किसको रेफर करेगा तो रेफर करेगा सेकेंडरी. Now suppose I'm having a program here. Now suppose now these are divided into different blocks. Now suppose the program is started from this block. The program zero है वहाँ पे स्टोर है. Now suppose it is starting from this one and ending here. Now this suppose this program consists of instruction number I0 से लेकर instruction number I99. Now suppose there is 100 instruction. Okay. Now what we have said that this program P0. Now this program P0 consists of how many instructions? Suppose I'm saying the instruction I0 से लेकर I99. There is 100 instructions. So when we will be talking about the memory allocation, okay, in continuous allocation, now what will happen? Now we know that. So before executing, now I have to this P0, this program P0 should be loaded to the primary memory. Why we are doing so? Because the access speed, okay, the data access speed for the CPU will be increased or CPU efficiency will be increased. So what I will do this P0 को लाके हम लोग क्या करेंगे मेन मेमोरी में स्टोर करेंगे. Now suppose this P0 is stored here. Now what will happen in the main memory now? Now this main memory, what will happen? Now this is a continuous allocation. So what will happen? Suppose the P0 started from this particular address. Now this is register number I0. Now it will be continuously going to store. Now यहाँ से लेके यहाँ तक आपका क्या रहेगा? This will be all your P0. This will be all your P0 because this is continuous allocation. So this is my instruction number. This is last instruction will be instruction number 9. Okay. So what is the benefit of this? Benefit of this is if I know the base address. Okay. Now what will happen? Now second thing you have to remember here. Now the address of this secondary address. Suppose the address is here 100. It will not be same. It will be something around 500 or anything else. The address of both these are different. Okay. Now this particular address are called physical address. This particular address is called physical address. Fine. Now in case of continuous allocation, okay. So now this conversion, this logical address to physical address is very easy. So what I will do? So I will take a base register. Okay. I will take a base register. क्या लेते हैं हम लोग? Base register. And what this register is going to store? Now this base register is going to store the base address of P0 in main memory. ठीक है? P0 का base address. Now in this case, the P0 का base address क्या होगा? It will be 500. It will be 500. Okay? It will be 500. Okay? This base register is always going to store what? It is always going to store your. It is always going to store your the base address. Okay? It is going to store your base address of what? The program P0 or the program which is currently executing. Okay. Now suppose the CPU requested instruction number suppose 50. Okay, CPU want to execute the instruction number 50. So I know that. Okay, now this is continuously stored. So what will be the instruction number 50? Now it will be base register plus the instruction number. Again, if it is continuously stored, so I know that it will be the base address. Okay, base address which is 500 plus instruction number that will be 50. Now at the address 550. Okay, at the address 550, it is going to store your instruction number 50 in your physical memory. So how we can get? So there is one more thing there. That is limit. There is a limit register. Now what the limit will be do? Limit will be check whether the instruction is within the limit of the program. Now here limit, what is the limit here? Limit is 100. If I execute beyond 100, like 101 or 102, now this is not accepted because these instructions are beyond this program. So the first of all, so I will check this. I will check. क्या करेंगे हम लोग? Check करेंगे whether the instruction is less than limit. Okay. If the instruction is less than limit, then if it is yes, so what I will do? I will add this instruction with the base register. Then whatever the address will generate, that will be your what? Physical address. That will be your physical address. Okay. It will be generated. I will check this one. If it is no, then I say this is a trap. If it is no, then it is a trap. If it is yes, then I will add this instruction with the base register of the program. I will add this instruction number with the base register so that I will get the particular instruction. So this is the case we have already discussed in the previous class with the continuous memory allocation. So is it clear to all of you? Is it clear to all of you?
Yes, sir.
Now, what is the problem? If I'm using the continuous memory allocation, one of the major problem is external fragmentation. Okay, external fragmentation, which is a major concern in case of memory allocation. Yes or no? If I'm using the continuous technique, okay, continuous memory allocation technique, then one of the major problem is your external fragmentation. So for that, because we know that the memory is very much limited here. Okay, as we know that the memory is very important concern while designing any computer architecture. So we have to optimize this memory. Okay, so we have to make sure that कम से कम memory wastage होना चाहिए. So what is the solution? Solution is non-continuous memory allocation. So non-continuous में क्या होगा? If this is my main memory, okay, this is my main memory. Fine. This is my main memory. Now suppose these are the blocks are available like this. Now what I will do? Now this P0 will not going to store continuously. So what I will do? So the P0 will be stored here. Now suppose in this block I am storing around P0 का instruction number 0 I0 से लेकर I49 तक स्टोर किया, ठीक है, क्या किया, आधा यहाँ पर स्टोर किए एंड रेस्ट P0 यहाँ पर स्टोर कर रहे हैं. Now suppose this is occupied. Now assume that these blocks are occupied. These blocks are occupied. Okay, this is occupied. Only 2 blocks are free. So what I will do? I will store half of the P0 instruction here and next instruction number here 50 से लेके what instruction number 99 तक यहाँ पर store किया. Fine. Now this is your non-continuous allocation. This is my continuous. This is your non-continuous. Now this address translation process. Now देखो, whatever we done, this address translation. This is basically logical address to the physical address translation. Now this address translation logic will not be going to work. Now what? Suppose it is instruction number 55 को खोला, ठीक है? Try to understand. Now if suppose instruction number 55, I'm talking about non-continuous. Now it is within the limit. Yes, it is within the limit. So what you will do? You will add the base register, which is your 500. Now suppose the base address is same here. Now I0 का base address यहाँ पर क्या है? Base address हम लोग क्या बोले? 500 है, ठीक है? Now what I will do? Base address plus 55. Now you can see if I do something. Now where is the 55? Where is the 55? Now this suppose this each block is 50. This will be and as a 50. Now 55 will be somewhere around this one, है कि नहीं? अब ये इंस्ट्रक्शन को फेस करेगा इस पॉलिसी में. लेकिन 55 कहाँ स्टोर है? 55 आपका यहाँ पर स्टोर है, यहाँ पर स्टोर है, यहाँ पर स्टोर है. लेकिन फेच वो कहाँ से कर रहा है? According to this process of address conversion, what I will do? 500 plus 55. It will simply add 500 to 55. It is for 50. That is going to fetch for this data, which is your invalid data. Again, it is your invalid data. Okay. So in non-continuous allocation, कहने का मतलब है in non-continuous allocation, this address translation will not be going to work. Again, is it going to work or not? Is it going to work in non-continuous?
No, sir.
What is the reason? If you simply add this base address, okay, this addition of the base address will only work if it is continuous. If it is continuous, that means same case of array. If I know the base address of array, so I can find any of this address of block. Okay, because we know that address array are stored in continuous fashion. Okay, if it is non-continuous, now this logic will not be going to work. Now what we will do for non-continuous allocation? Okay, the address translation can be done with the help of paging and segmentation. Okay, paging and segmentation. There are two techniques we are using. One is called your paging. Second one is called segmentation. Okay, second one is on segmentation. These are the two techniques which we are going to use. Okay, for the non-continuous memory allocation. Okay, for the address translation, that means to translate the logical address to physical address. I hope it is clear still now to all of you, because now we are going to discuss about how address translation can be performed in non-continuous. Is it clear? Any doubt? Any doubt? Still now, any doubt for anyone? Anyone having any doubt? Anyone having any doubt? So is this clear, the concept of continuous allocation and non-continuous allocation? Yes? Is it clear what by continuous allocation?
Yes, sir.
Okay, fine. If it is clear, then it will be easier to understand. Okay. Okay, fine. So this address translation technique, basically this address translation technique is only for the continuous, and this thing is done by memory management unit. MMU होता है. Okay, there is a device, hardware device called. Okay, there is a hardware device which is called MMU. Now these two combinedly present in a hardware device, which is your MMU होते हैं, which is your memory management unit. This is memory management unit, which will convert basically your physical address to the logical address to physical address. Fine. So let us continue our discussion with the, how we translation can be performed in your non-continuous allocation. Okay. Okay, so before starting the address translation, so let's understand some basic concept how the memory is actually divided. Now, as we are studying operating system, so now I will assume there are only two memories. Okay, we will not talk about the cache memories and the registers. So I will say there is a secondary memory whose capacity is very large, and there is a primary memory whose capacity is very less compared to the what? Compared to the main secondary memory. Fine. Now, what happened in the main memory? Now, this main memory are divided into equal blocks. Okay, of fixed partition. Okay, now here what we are doing. Now, each of this main memory, okay, divided into block of fixed partition. Now, what we are doing, now suppose this is my entire memory है, ठीक है, suppose this is my secondary memory. Now हम लोग क्या कर रहे हैं, अब इसको हम लोग blocks में divide कर रहे हैं, and it is a fixed partition. Okay, we already studied fixed partition. कहाँ पे पढ़े थे हम लोग concept? We have studied the fixed partition concept in continuous memory allocation, where we are having the problem of internal fragmentation. Fixed partition means if one block can be used for only one program, I cannot further partition this. Fine, is it clear? What is fixed partition? Once I made the partition, I cannot make further partition to this block. That means if I once made this partition, I cannot make further partition. Okay, clear? So what I will do, so I will divide this main memory into different blocks of fixed partition. Again, this should be of equal size. If it is a variable partition, okay, if I say, now assume that why we are considering this a fixed partition. Now suppose if this is, let me take 1 KB, okay, each partition is 1 KB, 1 KB. Okay, now suppose if it is variable particles, now suppose this one is 1 KB, this one is 4 KB, this one is 10 KB. Now the problem here, if it is not fixed size partition, it is very hard to convert, okay, translate the address. Okay, if it is not fixed size partition, अगर fixed size partition हम लोग नहीं लेंगे, तब क्या होगा? आपको address translation बहुत मुश्किल होगा. Now because what we have to do, I have to place this secondary memory process to the primary memory. Okay, so that is the reason what we have to assume. Now we have to assume all these partitions are fixed size and same. That means if this block is 1 KB, then other blocks should be also 1 KB. All this block will be 1 KB. All this block will be 1 KB. Is it clear this point? If this point is clear, your main memory or secondary memory will be divided into blocks which is of fixed size partition of same size, and these blocks are called pages. Now these blocks are called, क्या बोलेंगे हम लोग? Pages बोलते हैं. Fine, these blocks are called pages. Fine. Similarly, the main memory is also partitioned into fixed size. Okay. Now I will divide this main memory also into the fixed size. Again, this fixed size means I cannot make further partition. Okay, and size of this main memory will be equal to each block. Size of each block should be equal to the size of each pages. Now, if it is 1 KB, now these are also 1 KB. Okay, these are also 1 KB. These are also 1 KB. Fine, and these blocks are called frames. These blocks are called frames. क्या बोलते हैं? Frames बोलते हैं. Okay, the first point is the blocks. Let me write the block. Okay, blocks of main memory. Okay, main memory is called frames. Okay, it's called frame, and which is equal to that means equal to in terms of size, which is equal to the blocks of secondary memory. Blocks of secondary memory, which is called pages. Okay, is it clear? Now this frame and this pages should be same in size. दोनों same size होना चाहिए. Okay, then only the address translation is easier. Now what we know that now there is a CPU, which is having what? Which is always generating a logical address. Which is always generating a logical address. So what I have to do now? I have to convert this logical address to physical address if the memory allocation is non-continuous. Okay, if the memory allocation is non-continuous. So what do you understand by non-continuous? Now suppose I say there is a process. Okay, there is a process. Suppose this process is there. Suppose I say the process consists of P1 and P3. Suppose there is a process which is having P1, P2, and P3. Okay, I can say this process P. Suppose this process P, which is divided into three parts, which is P1, P2, and P3. Okay. Now each of this required 1 KB. So I have assigned. Okay, what we have done? Now we have assigned 3 blocks. Fine. Now suppose this process is 3 KB. Process is 3 KB. Okay. Now what I have done? I divided into 3 parts: P1, P2, and P3, and I have assigned this process to 3 blocks because each block is what? 1 KB. So हमने 3 इसमें assign किया. Now what I will do, so before execution, what I have to do, now I have to shift this process, yes or no? Now this process P should be shifted. Now this process P should be shifted to the main memory. Now as this is a non-continuous allocation, so I can place this process anywhere. Okay, suppose I have placed P1 here. Now suppose I will place P3 here, and I will place P2 here as for the backend block. Okay. So what we have done now, this process are stored here. Okay. Now I have placed एक block यहाँ पर रिजर्व किए. Now एक block यहाँ पर रिजर्व किए. Now एक block यहाँ पर रिजर्व. Now is it continuous or non-continuous? Is it continuous or not continuous? Now you can clearly see here. Now here it is continuous. One more thing you remember. Okay. This basically we are assumed here. Initially we are assumed that in secondary memory the process are stored continuous manner, but it is non-mandatory. Okay, so when we will study about the different types of disk management and file management, so we will understand that this process can be also stored non-continuously. But for the concept of paging and segmentation, we will assume the process in a primary memory, secondary memory, are stored in a continuous manner. Is this point is clear to all of you? I'm clear. So we are assuming that in a secondary memory, the process is stored continuously, but it is not mandatory or true with every cases. Okay. As we will discuss the disk management and file management में पढ़ेंगे हम लोग, तब आप लोग देखेंगे कि यहाँ पर भी जो secondary memory में जो process store होता है, वो continuous store नहीं होता है. because continuous store होने में हमेशा external fragmentation होगा. That means wastage of memory. Fine. So what we do, we will assume that the process are stored continuous here. So now we can clearly see that this when we are stored with process P, when the process P is stored in a main memory, now it is not stored in continuous manner. Now you can see the process P का P1 जो part था वो यहाँ पर store है. Now the process P का P2 का part कहाँ पर store है? ये यहाँ पर store है. And process P3 part कहाँ पर store है? यहाँ पर store है. Okay. Add is a fixed size partition. This place, that means each block में एक ही process आएगा, मतलब एक ही instruction आएगा. आपकी block process बोल सकते हो. Okay, I cannot place like P1 यहाँ पर, P2 यहाँ पर. Okay, it is not possible because it is fixed size partition. So once it is assigned, I cannot further partition. Okay, now the question comes initially जो हम लोग पढ़ रहे थे. Now what I have to do? Now this time what will happen? Now when the CPU want to access, now this generate a logical address. I know that logical address is here, but CPU will not interact here. What the CPU will do? CPU will going to interact main memory, which is your physical address. Okay, which is your physical address. Now how we can convert Okay, how I can convert this logical address to the physical address. Okay, the very big question here rises here. What is the question? Now, in non-continuous allocation, a non-continuous allocation है ये. If it is a non-continuous allocation, how I can convert this logical address to the physical address? Clear this point till now? Any doubt? Anyone having any doubt? Any doubt? Anyone having any doubt? Yes? Any doubt? Anyone? Okay, so what happens? So whenever it generates, okay, so let us say resume the class. So as we have seen, so we have the secondary memory. So this is secondary memory. Right? Now this secondary memory is divided into different parts, or we can say the pages. Okay, these are divided into pages, and these pages are of fixed size partition. Fine. Now these are called pages. Okay, and similarly, I am having a primary memory whose size is less compared to the secondary memory. This is my secondary memory. This is my main memory. But block size will be same. Number of partition will be same. Okay. And this block here are called frame. These are called frame. Okay. Both the size of the frame and size of the pages are same. Now, as we know, if the CPU, so whenever the CPU required any instructions, okay, so it will generate a logical address. Fine. So that is my CPU. So it generates the address, which is your logical address. Fine. Now this logical address having two things. One, I will say P and D. Now P represent your page number and D represent your offset address. So this is your offset. You can say this is your offset or instruction offset, and this is your page. Now what we have to do now to convert this logical address to the physical address. So now suppose, for example, I'm assuming there is a program P which is occupied 3 pages. Now the program P is occupied page 1, page 2, and page 3. Okay, the program is occupied 3 pages. Now assume that each of these pages is 1 KB. Now as I already said, okay, we are assuming that the programs are stored continuous in secondary memory, but it is not so. Okay, it may or may not be stored continuous. Okay, now suppose this program P is placed in a CPP and each of one is 1 KB. Now what will happen? Each of this block will be also of size what? 1 KB. Each of this block size will be 1 KB. Now suppose assume that at any instant of time, these are the block which is already occupied in the main memory. These are the block which is already occupied. This block is occupied. This block is occupied. Okay. Let me say this block is also occupied. Right? Only 3 blocks are available. Okay. So what I have to do? Now I have to shift this program to this main memory. Why so? Because so that we can access this program more speedily or effectively. So what I can do, I can pick these pages. Now I can store like page 1 here. Okay, this page 1 is stored here. I can store page 2 here. Any random. Okay, you can store any page anywhere. It's not compulsory that you have to store in this way. Now page 1 can be here, page 3 can be here, page 2 can be here. But they are all of same size. Okay, they are, remember, these are all of same size. Fine. Now here what is happening, now address of this one, suppose it is 100. Now address of this one, suppose it is 200. Address of this particular block, suppose it is 300. Okay. This is the particular page number address, so this is 100, 200, 300. Now here address will be something different. Now suppose this is 200. This address will be something around 500. This address will be around 600. Alpha physical address. Okay, this is my physical address. These are my logical address. So I have to convert this logical address to physical address. And now you can clearly see here. So pages are stored in different frames, or we can say the program it is stored continuously in the main memory. Now it is stored in non-continuous manner in a or we can say as the program which is stored continuously in secondary memory is now stored continuous in main, and both of them having the different, we can say different address location. But the question arises how to convert. Now what will happen? Now this is my physical address. Okay. Now how I can convert this logical address to physical address. Okay, the question is how I can convert this logical address to physical address. Now how it is possible? So I will take a data structure. Okay, so in between the CPU and this, so I will take a data structure which is called page table. Okay. This is your page table. What is this? This is page table. Or page table it is simply a data structure which is, that means it is a logical implementation. Okay, it is a logical implementation. Fine. Now for every program, second point you have to remember that for every program, this page table will be different. For each program, or for program B, it will be different. If I say for program B1, the page table will be different. If I say page program 3, the page table will be different. And what is the entry of the page table? The number of blocks that present the page table will be exactly equal to number of pages the program is required secondary. Now in this case, if it is required 3 pages, the page table entry will be 3. Now suppose assume that some process P1 it's required suppose 10 pages to store. Okay, so it requires suppose 10 pages. Now P1, P2 up to P10. Now what will the number of entries? Number of entries, there will be 10 entries. Okay, I can say 1, 2, 3, 4, 5. 5, 3, 4, 5. Suppose some process P2 is having only 5 pages. Now P1, P2, P3 up to P5. Okay. Now how it is represented? The number of page table entry will be represented. Now this will be our page 1. This will be our page 2. This will be our page 3. This will be our page 4. This will be our page 5. And the base address of the space table, it is represented by PTBR, page table base register. Okay. The page table base register is responsible for finding the base register of this base table. Okay. PTBR. Remember this one, PTBR is a base register which stores the base register of any base table. Now the question comes here, what does this base table consist of? Now this base table basically consists of the particular frame number. Now what I said, this is my frame. So suppose page 2 is stored in frame 2. Okay, so I will write as a frame 2. Now I've said page 1 is stored in somewhere 1, 2, 3, 4, 5. Okay, frame 5. So I will write the frame 5. Clear? Similarly, page 3 is frame 6. So what we have done here, now this page table consists of page Okay, now single instruction is frequency. Now this is basically that does not have the frame number. They basically have the base address of starting address of frame number. Now this particularly have what is the starting address of this one? The starting address is 200. Now it will be have 200. Now it will be have something 500. The starting address. Okay, remember. It basically consists of the starting address of the particular frame. Now if this frame is 600. Similarly, it will also have some address, like suppose 300, and it will have some address 100. Okay, so each pages, that means it is पेज वन आपका कहाँ पे स्टोर है फ्रेम 5 में और फ्रेम 5 का बेस एड्रेस क्या है 200. तो ये पेज टेबल का मेन काम है. ओके, तो पर्टिकुलर पेज टेबल जो आपका है ये पर्टिकुलर इंफॉर्मेशन स्टोर करेगा. Now how it is transformed? Now particularly this, when I request this logical address, this page number is referred to the particular frame number. Okay, अभी क्या होगा, ये particular frame number. Now हम लोग क्या करेंगे, पेज नंबर हम लोग पेज टेबल में लिखेंगे. Now from where I will find the what particular frame number. What I will get? I will able to find the particular frame. है कि नहीं? इस पेज ये पेज पर्टिकुलर कौन से फ्रेम में है, फ्रेम नंबर का बेस एड्रेस हम लोग निकालते हैं. Then what is the offset here? The offset is particularly say that the instruction. Now if I say the page 1, अभी यहाँ पे देखते हैं page 1. If I say page 1, suppose consists of 10 instructions. Okay, it is 10 instruction I10 to I10. Now is this 10 instruction continuous here? Yes. This 10 instruction continuous. Now if I say find the instruction number 6. Now where this instruction number 6 is stored, now you can see the instruction number is 6. Now this whole data is continuous. Here also the whole data which is P1 is stored. It will be also in continuous manner. Now what will happen? Now this offset address will be same. This offset address will be same in both the cases. It will be not going to change because it is continuous, it is continuous. Now it will be. Now what will happen now when I combine this offset address? Now suppose I say frame address is 500 here. It is 500 plus what is my offset address? My offset address I'm saying 9. Now if it is 9, so what will it give? It will give 509. So it will give something 509, which will be your physical address. Clear? Is it clear? Which will be your physical address. Now this gives your physical address. Now what we have done? Now we have having the logical address. Now this logical address is converted to the physical address with the help of this page table. Okay, and this is your data structure. Okay, which this will be used for implementing this translation, address translation concept. And PTBR, remember, this is my register, which is stored in the program controller, which will be have the base address of the page table. And second point, you have to remember, every program have its own page table. For different program, we will have a different page table. And what is the entry of the page table? The number of pages that require a program to store. Number of pages. Okay. And the reference will be the frame number, and basically it will store the address, base address of particular frame number. And this is how we are converting a logical address to the physical address. Fine, so this is the basic concept. Now this concept can be further implemented as paging, single paging or single page table paging. We can have multiple page table paging, and even we are also having invalid bit page table. Okay, so in the next lecture we are going to discuss these different types of paging. Okay, so hopefully we complete the different types of paging, then we will see other technique. So hopefully it is, I think it is clear to all of you. If you are having any doubt, you can ask me. If you are having any doubt, we will stop here the class. Okay, thank you.